Number 2 is 8x squared minus 14x plus 3. Number 4 is 5x times 7x minus 3. Number 6 is x minus 8 times x minus 4.
Would it be okay if we said,
Uh-oh, are we slipping?
x minus 4 times x minus 8?
No, that's terrible. Yes, it's definitely fine. The order of the way the factors are written doesn't matter because of the commutative property. Number 8 is 2x minus 5 times x plus 6. Number 10 is negative 6 and 6. Number 12, is negative 1/3 and 1/2. 14 is negative 4 and 7. 16 is 9 meters by 12 meters. Excuse me, again. 18 is 2x squared plus 9x minus 5. 20 is 8a times 5a minus 4. 22 is 8x minus 3a times 4y plus 5b. 24 is 15 times y plus 4 times y minus 4. 26 is x plus 8 times x plus 5. Excuse me. 28 is 3 times x plus 6 times x minus 2. 30 is 4x plus 5 times x plus 6. 32 is 4z squared times 2x minus 3 times x plus 1. 34 is 6y squared times 3x squared minus 4x plus 6. 36 is negative 7/4 and 2/3. Excuse me. 38 is 5 and negative 9. 40 is 11 and negative 11. Plus or minus 11 is fine. Way to write that. 42 is 4 and 2/3. 44 is 7 centimeters, 24 centimeters, and 25 centimeters. 46 is x equals 10, and then 8 feet by 12 feet. And 48 is x equals 12, and then 14 feet by 32 feet. What questions do we have today? 16. Tamika wants to double the area of her garden by increasing the length and width by the same amount. What will the dimensions of her garden be then? That's a fun problem. I love it.
It feels way too easy.
Okay. Nobody sit next to her. Don't let her breathe on you.
She definitely will sit next to me.
Okay. So, it seems way too easy. What'd you get as your answer?
I got it wrong.
Okay. Okay. So it wasn't as easy as you thought.
I just had 12 and 8.
I could have told you that to begin with, but yeah, no, that would make quite a bit larger area, right?
It said double. I was like,
It doesn't say to double the lengths. It says to double the area by adding the same amount, but you didn't even add the same amount. You added 6 and then 9. Okay, so she's got a patio thingy-mabob or something. What does it say? I don't know. Who cares? Okay. She's got this guy that's 6 meters and 9 meters. She wants to double the area by adding the same amount. So she wants to add some amount to both of them and double the area.
the area is 54.
The current area is 54 meters squared. That's true.
And then doubling it is 108.
Doubling that is 108.
Then x plus
What am I doing?
6
By the way,
times x
Not plus, times. I don't know if you said that or not.
I said
I kind of half
I
listened.
added the
I started to speak, and so I didn't want to listen to about the beginning and the end of what you said. Yeah.
Okay, that makes sense.
You wouldn't add the x's. Is that what you just said?
Well, x plus 6 times x plus 3.
Right, right. Yes, that's correct. Okay, I don't know if you're also saying something wrong, but that is correct.
That's what
I'm probably just hearing things. Okay, you should know that my brain is not braining very well today. I feel good today, but I'm fatigued. I've been running on lots of emotion, lots of fatigue and whatever else, and whirlwind of weekend and things and all the things. I feel good, I feel happy. I don't think I'm gonna bite your head off, but my brain isn't braining well today, so I'm liable to make stupid mistakes often. I know that's like normal, but maybe worse than normal. So, you know. Okay, yes, you are correct. We want x plus 6 times x plus 9 to equal 108. Now we got to solve for x. So what should we do? Can't combine like terms because those parentheses. We should. We've got it so that we're going to ultimately factor, right? But it is factored, but it's not equal to 0, so we've got to break it and then fix it again, right? So we got to FOIL first, and then in a minute we're going to factor after we do some other things, all right? So x times x is x squared, and then plus 6x plus 9x plus 54 equals 108. Now what? Combine like terms. We're going to go ahead and kind of do two things in one step. So where are the like terms? 6x and 9x, yes, absolutely. But we don't want to do it that direction. So you're thinking right and wrong all at the same time. Because we want, in our hopes that this will factor, we want everything on one side and 0 on the other side. So we wouldn't subtract the 54, what would we do instead?
We would
Subtract 108, yeah. Okay, so then we end up with x squared plus 15x minus 54, right? Equals 0. All true. What's up? You're not, in fact, dying. We're glad. She said that you're like fatally ill, but coming anyway.
Yeah,
Okay.
I'm getting you all sick.
I might be embellishing slightly, but you know. Now what?
Now, refactor.
Refactor it. So it's probably going to factor because it's a textbook problem, right?
Yeah.
If this was real life, we'd end up having to like complete the square or something, or quadratic formula, but this is a textbook problem, so it's probably going to factor. So 54 is kind of ugly, so you know, at this phase, you get enough practice and you may not need to like list all the factors, but 54 is kind of weird, so let's take a second to list the factors of 54. So what are they? 27 and 2, 54 and 1, 9 and 6. Do we have any that look like they're going to work yet?
9 and 6.
9 and 6 look like they might work. 9 and 6. Can we add or subtract those to get 15?
Yeah. Wow.
So did we find it?
Yeah.
Y'all are wrong. y'all are wrong. We didn't find it.
Oh, well, you have to move them and then solve for x.
We didn't find it.
Something's wrong here.
9 times 6 is positive 54.
So they're
wait, if we did negative and
That would give us negative 15. It didn't work.
so it's not right.
So it's not right.
Oh, it's so easy.
Crazy.
So we need one positive and
The textbook tricked us.
no, we tricked ourselves.
We might have made a mistake.
I think both happened, Malcolm.
Well, I think we might have made a mistake before because what we're trying to factor will never give us the answer that's in the book.
True.
Because 9 times 12 is not 54. And negative 9 plus negative 12 is not positive 15. Because the answer in the book is 9 and 12. So let's roll back the tape and see if we made a mistake somewhere.
Aren't we supposed to subtract 108?
So let's see, do we write those first parts right? 9 and 6. Let's read the problem again, make sure we read it good. Wants to double the area of a garden by increasing the length and width by the same amount. Okay, so the original was 54 times 2 is 108. X times x is x squared. X times 9 is 9x. X times 6 is 6x. X times, what am I saying?
6 times 9 is 54.
6 times 9 is 54, and we want that to equal 108. I hear people shushing, so it's probably fine. But I'm going to look anyway. Is this the shushing or the Somehow we're ending up with we're not ending up, we're ending up with something that isn't really actually factorable.
Maybe the book made a mistake.
Or we did.
The book was.
The book's always right.
No, it definitely isn't.
That's not true.
It definitely makes mistakes sometimes.
Maybe still change.
It's not even allowed.
Negative 15. What's 15 squared? 225, is that right? You'll remember or learn this if you've never seen it before, or remember it. What's 15 squared? 225?
I do
Yeah.
remember this. I just don't like it.
You remember not liking it?
Yes. I don't remember how to do it. I remember doing it and not liking it.
It's just a rememberize thing.
Well, I didn't remember as it is.
Square root of 333. Is that right? 225 plus 108 is 333. What's square root of 333?
Something.
3 times the square root of 37.
What?
What?
What's the square root of 333?
3 times the square root of 37.
Okay, give it to me in an approximate. Normally in math class I want the other, but 18 point what?
24.
18.24. So that'd be 3.24 divided by 2 and some negative number, which we don't care because we're not going to shrink the thing, we're going to increase the thing. What's 3.2? That just push divide by 2. Oh, just kidding. Don't just push divide by 2 because you got to subtract the 15 first. I'm not seeing anything wrong with our setup. Are y'all seeing something that I'm missing? It's 1 point something?
At 1.62.
Great. Which would make this, the answer be like 7.62 and 10.62.
Can we break that down even more because 54 divisible by 3.
54 divisible by 3. What? I'm confused. Where are you at?
So 54 divided by 3 is 18.
Where are you getting the divided by? Oh, like reducing this? No, because there's not a 3 or something here. It has to be all of them. It's a good question. I'm not seeing anything we did wrong. She wants to double her garden by increasing the length and width by the same amount. What will the dimensions be? So it was currently 6 meters. Between that, we want to add some value X. It used to be 54 meters. Just for the sake of everybody's sanity, everybody push 9 times 6 in your calculator.
54.
Great.
54.
Now push times 2, just for the sake of everybody's sanity.
108.
108. Great. That, and she wants it to double, which would be, that would be double. So we want that to equal that. Because that's how we calculate area.
If she wanted to make her life easier, she could just multiply 6 times 2 and just make it like double as wide.
Well, that would be 4 times as big. Oh, you mean just changing one of the things? One of them. Yeah, but she wants it to be.
She's just going to be annoying and make us do extra work.
Just guesstimate and.
Yeah, I don't think we did anything wrong. I don't think. We'll all sleep on it and assume that it's wrong.
This is some next level gardening.
So they added
Seriously.
3 to both. What's 9 times 12? That's like 108, right?
Yeah, 108.
So how did that work?
The book messed up. Yes.
Well, their answer works though. So why doesn't our math work? Before we spend any more time on this, we may come back to this. But before, do we have any other questions on this lesson?
Can we do 22?
I tried.
22 is easy. You just forgot something. Okay.
Yeah.
I tried it and I didn't think I'd get it right, but I got it right.
We
Nice.
also need to do 2 because, like, for some reason, I
Yeah,
messed
I
up on
didn't
2.
do 2 either.
It was kind of weird.
We did one like it in class on Thursday. I specifically did one like it so that we could do it.
We did like one of every.
We did a number 3, which is exactly like number 2, but I guess we can do it if y'all are being noobs and forgot to go back and watch the video if you're stuck. This is for you. That's why I record class, just in case we're confused about like why I don't like waste my time every day. Of course, the video isn't actually out, but you know, you didn't go and look anyway. But this video, I record class for you people that are sitting here in class. So that if there's something you forget or you didn't get down good or need more things, you can go back and watch it. Because I'm going to tell you right now, there's nobody else watching this video.
I got next.
It's for you.
I wouldn't.
That's true. And the video isn't out because of all the things. It should be out today, probably. But it wasn't out. So you do actually have an excuse for once. Well, we were doing, what did we say? Number 22. 22 is easy, but if you don't remember how to do it, maybe it's scary. 3D2 XY plus 40 BX.
These are just a bunch of numbers. Oh, spooky, scary. Oh no.
A bunch of letters.
Minus 12XY. Oh, no, just kidding. 12AY. Oh, did I copy something down wrong? Oh, no, I didn't. Okay, yeah. Okay, yeah, there's a few layers to this problem. Yeah. I follow you. Okay. Yeah. Yes. It's not quite as straightforward as I thought at first glance. It's not hard, but it's harder than I thought it was. How many terms are there? 4 terms. So we're probably going to factor this by grouping. That's probably our goal. So the problem as it stands, oh no, just kidding. No, this is pretty easy, actually. We don't have to. I thought we were going to have to rearrange stuff. We're not going to have to rearrange anything.
Because it gives us all four terms.
Well, it gives us all 4 terms, and it's already in the right order. I thought we were going to have to rearrange it, but looking at it again, we don't have to rearrange it. I will tell you when we get there how you could know if you were supposed, you'll get to a point and you should have rearranged it. And you need to go back and rearrange it to make it work. So I'll explain what I'm saying with the rearrange in a minute. Sometimes you have to move these around, and I will explain that, but just in a second, because it'll be more clear if I show you things. So we're splitting it down the middle. Then what do? What's the next step in factoring by grouping?
Take out the common factor of one side. And
So what is in common in the first term?
X.
X and what else?
2. Oh, yeah, 8.
8. Take out an 8x. We take out an 8x out of the first term, what's left?
Y.
And
4.
4. So 4y. Remember that when we're factoring out, we're doing GCF, you're dividing it. So this is this divided by this, and this is what's left, right? So we take a 8x out of the 40bx, what's left? 5b, right? So plus 5b. Now, you might notice that the signs don't actually match, right? We see what I'm talking about there? The signs don't match. So, but they are exactly opposite, right? So what can we do to make them match in a minute? Well, this is plus plus and this is minus minus. We need it to be the same, exact same. What? Yeah, so, well, not multiply, but we're going to pull out a negative, which will flip these other ones. So that's going to flip these to positive, right? So when we do our GCF on this one, we're going to factor out a negative. Negative what?
3A. Yeah, 3A.
3a. And then what's left when we pull out a 3a? 4y plus 5b. Right? Okay, so if you have a problem like this and these do not match, then you probably needed to rearrange to begin with. So, and the first thing, there are two things I'm looking at the beginning before I even start to decide whether I probably need to rearrange or not. One is the signs need to either match or be exactly opposite. So like if it was plus minus and then plus plus or something, that wouldn't work. It's a bad example. But like if it was not exactly opposite, if it wasn't the same or exactly opposite, then I probably need to rearrange, right? Also, if there's not a common factor in the first two and then a common factor in the second two, I probably need to rearrange, right? I'm not done yet, right? I can do another thing. What can I do now?
Get rid of one of the 4y plus 5b.
Not really get rid of it, but factor it out, right? Kind of. So I'm factoring out of this term and this term a 4y plus 5b. What's left in the first one? 8x, right? In this whole thing, yeah? And then what's left in the second one? Negative 3a. Accurate.
It's okay that no, I didn't do that. I thought that was switched.
The book writes it the other way around, which I don't like doing because I like to think about what we're doing and we're factoring out that other one. So I always write it this way.
I did something completely different but got it right. So
Did you?
I did.
What'd you do?
I kind of did the same thing as I did with like all the others. I just placed well, I'm looking at my steps again. So I found the multiples of negative 15 and 32. I placed x in the beginning of the parentheses and y in the beginning of the other. And then I just I did the guess and check, but it worked. Got it. But it was easier because I knew I had to get 40 and 12. No, negative 12.
That sounds like a very difficult way to think through it, but if it works in your head, that's great. That's fine. That's not a problem.
When you don't get like a single answer, like x is equal to z, it kind of annoys me. Like all
Okay,
that.
so I get that you've had that feeling for a long time. You're gonna have to like hardcore get over it. Like push yourself to be like, no. Because, and I'm stressing that because that itch is gonna, if you don't like put some cream on it, you're gonna scratch it, and then on a test you're gonna scratch it, and you're gonna get x equals 12 on a problem like this, somehow, magically. And so put some cream on that, and I don't mean that any weird way, like I'm talking like the pink stuff, itch for itches, yeah? Good Lord, teenage brains.
They make perfect sense.
No, false, false, on top of false. Okay, yes, we can. And then we should probably look at the next lesson. Number 2 is easy. I'll remind you, and when the video comes out, hopefully today, probably today, there's a video, in class on Thursday, we did number 3 twice, or I did it twice. So I showed you 2 different ways to think about it. I'm only going to do it today, however people remember and tell me what to do it. I'm only going to do it once today. But what do we do to solve number 2? Okay, what do you mean by that? Yeah, so the sign changed, right? Because when you do it, it will flip. We could do the factor and go back. It'll be different, so that's accurate. And then, yep, and then we're going to FOIL it out. Absolutely. First, outside, inside, last. X times
What the other way was.
x times x is x squared. X times negative 1/4 is what? 4th x, and then negative 3/2 x. I'm going to change this to 6/4 so that I can do the next part in my head without having to do craziness. And then negative 3/2 times negative 1/4 is what? Positive, right? Because negative times negative is positive. So positive 3/8 equals 0. Combine like terms. And we end up with x squared minus 7/4 x plus 3/8 equals 0. Now, there's a few things, this problem tells us to write this in standard form. Excuse me. There are a few things that make something in standard form. What are they?
That is like x is positive, or a is positive.
A is, so what is the generic standard form? Let's start with that.
Ax plus b.
Ax squared
Squared plus by.
bx.
Bx. Dang it.
This is a quadratic, not a. You're giving me the standard form of a linear function. Plus z equals 0. Okay. At standard form, a has to be positive, is what Malcolm gave, which is true. There's one other thing.
They have to be
Integers. Yeah. So a has to be positive. A, B, and C have to be integers.
So no i's.
So no i's, no fractions, no decimals, no square roots. So we're not in standard form yet. So what do we need to do?
Make it standard form.
Right, how? What?
Turn it into not fraction.
True, how? What she said was turn it into not fractions.
By making all the denominators the same by multiplying the top number and the bottom number.
I don't need them to be the same.
What?
I need them to go away.
So multiply the numbers by 4. Oh yeah, because
Not by 4.
By the denominator.
Okay, we're walking down the rosy path. We're getting there. We multiply everything by the LCD screen. In other words, the least common denominator, right? So what's the least common denominator?
1?
No.
4.
Least common, let me change it to its other form. Least common multiple. Multiple means bigger, the one that they multiply to get. Factor is the one that's inside of it.
8.
16. 32.
Don't know.
64.
How about 8? Because 8 times 1 is 8. So check.
I said
4, you did after saying 500 other things. So it didn't count. 4 times 2 is 8. So we can turn both of these into 8. So that's the least common denominator between the two. Yes? Yes? Happy days are here again? Good? Great. Now, I will throw out there that you could use 64, but then you would have to reduce later. And divide it by something and to reduce. So you could use 64. You could use whatever else, 108 probably, whatever, right? But
128.
if you don't want extra work, you know, just do the smallest one. 8 times x squared
8x squared.
is 8x squared. Beautiful, right? And then when we do this, 4 goes into 8 twice, so it's 2 times negative 7, so negative 14x. 8 goes into 8 all the ways, turns into 1. 1 times 3 is 3.
And then
8 times 0 is 0.
Okay,
We did it.
We did it.
that checks out.
It does check out. Let's look at the next lesson in 6 minutes.
Okay.
We got this.
You
Oh,
seriously
no.
think
6
that?
minutes?
Yeah, y'all are slow. It's fine.
No,
Next
we
lesson
have,
was easy, so it's fine.
no, we have,
I left that.
What numbers did we do?
we have 21 minutes.
Oh, you're right. Yay!
Oh, thank you.
This class is lasting longer. Good. We have enough time to, you know, like actually take questions, which you're going to have.
We just
So,
started at 8:50.
Yes, we already have.
what numbers did we do?
2 through 40.
Okay, that's what I thought. But I wanted to make sure current me agreed with past me. Okay.
Oh, I did.
Because sometimes it doesn't. Sometimes I think, what was I thinking? That's not enough problems. Sometimes I was thinking, well, rarely, but sometimes I'm like, why did I give so much? But mostly it's, why didn't I give those problems? But, you know, it's fine.
But I am curious why you didn't do the whole page. Instead
Because who
Malcolm?
7?
Malcolm,
maybe.
Because we didn't need those.
we're happy about it.
We could have done 42 through 46, but we didn't really need them because we get.
No, just do 42 to 46. I'm good with that.
Just the.
Oh, just those and not the yeah, right. No, I was saying in addition to. We could have, but we didn't. Okay, number 2 is 4i times the square root of 2. It's worth noting, I feel like I said this before, but I should say it again. On these types of problems, there are sometimes the problems in this class and then that carries over to pre-cal. There are sometimes the problems, and this is one of them, that if you do not show your work, like show where you got there, show that you understand how to do it without the calculator, I will count it wrong. Well, then you need to learn how to do it yourself. Because like numbers 2 through 6, I guess. And then again, 18, well, all of them, 18 through 34. If you don't show your work, but especially on like 18, 20, 2 through 6, if you don't show your work, I'll count it wrong. Probably all wrong. So you need to show what you have done, because the point of it is that you know how to do it. I know that the calculator will spit out an answer for you. Actually, if you try to do number 2, as it's written in the calculator, it's going to give you some sort of domain error or something like that.
Yeah.
But you know, so you have to be able to do the I, but I want you to show how to get 4 times the square root of 2 as well. You need to be able to show that. So 4i times the square root of 2. Number 4 is negative 72 times the square root of 3. 6 is negative I. Excuse me. 8 is plus or minus I. 10 is 5 and 3. 12 is 6 plus 2i. 14 is negative 14 plus 8i. 16 is 16 61sts minus 7 61st I.
That doesn't sound like a pretty number.
It is a little bit ugly, but it is in complex form, so that's what we want.
It's the correct.
Number 18 is 11i. 20 is 10i. 22 is negative 42i, excuse me. 24 is negative I. 26 is 16 plus 2i. 28 is 3 plus 7i. 30 is 5. 32 is 18 minus 30i. Excuse me. 34 is 1/2 minus I. 36 is plus or minus I. 38 is plus or minus 5i. 40 is plus or minus 3i times the square root of 2. What questions do we have on those?
40?
40. Okay, great. It's pretty easy, but I guess we'll do it anyway.
I'm just confused on the.
And then I want to do 10.
I'm just being funny.
You're hilarious.
I know. What? You're angry? What'd you say?
You got all of them right. I'm impressed when I'm angry.
Impressed and angry.
Or you're impressed when you're angry, or you're.
She probably just used photo math. I mean, don't worry about it. Not this time. I've said it before and I'll say it again. Photo math is a useful tool. Just be careful not to like rely on it, because then it's not a useful tool. It's like killing you. I don't care about the cheating aspect. I care about like you learning. And if you're using photo math to learn the thing better, use it. If you're using photo math to get your homework done, that's like a total waste of time. I give you a completion grade on your homework, so don't be stupid. Don't waste your time. Duh. Yeah, no, that's great. I 100% approve of you using the tools correctly. That's great. I'm glad they exist. They're useful, or can be. Just don't use them stupid. Don't use them like a public schooler. We're supposed to solve for x, so what should we do? There's kind of two different ways to solve this problem, but there isn't one yet.
Subtract 108.
Great. Totally acceptable way to solve this problem. That is a way you could solve this problem as well.
That does look like a 7.
What does?
You're 8.
Which one? Oh yeah, I guess I can kind of see that. Okay. It's an 8.
Exactly like a 7.
No, it doesn't. It's a 7 with a little turn and a little thing. So it does not look. That's not what I said, but it does kind of fit. I was trying to say twirl and it came out I don't know what, so who knows. I did not, I don't think, say turd. You can go check on the video. But, you know, it kind of fits. It's kind of a little turd on the back. It's even in the right place for a turd, so, you know, it works out. Okay. Equals 6x. Now what?
Divide
Squared.
by 6.
Divide by 6. I love it. Good job. What is negative 108 divided by 6?
36. Negative 36.
Negative 36.
Square root.
Square root.
And then you need
You do, but are you sure that's right? Because the key could be wrong, but but that is not going to match what the key gets. I think you did this division wrong. What did you say? Or the key's wrong. Both are possible.
It's negative 18.
That'll mean you get all of them right. If the key's wrong.
I get 18. Yeah, there's your mistake. We found it.
Oh, dang it.
Okay, now what? Square root it. We take the square root of a thing, what do we get?
X equals.
Not what I'm asking yet. We're there in a minute. X equal, well, you might have been about to say it. What do we get? What was going to be the next words you were going to say?
The square root of negative 18.
Okay, so no, that's not what I'm looking for. When we take the square root of both sides, what do we get? We always have what?
Yeah, x equals.
Wait, no, stop. Stop saying x equals. We always get two answers. What two answers? That's what I'm going for.
Plus and minus.
Plus and minus. That's what I'm looking for. So x equals plus or minus. Square root of a negative is going to give us what? I times something. Are there any perfect squares inside of 18?
No.
There definitely are. Definitely is. 9 isn't. 9 and 2, yeah? 9 times 2 is 18. This is what I'm talking about in the, you need to show your work. You need to show this. That you knew that this is how the calculator got 3 times the square root of 2. Right? This is what I'm talking about. So our final answer ends up being x equals plus or minus 3i times the square root of 2.
Yeah, where'd you get 3?
Because the square root of 9 is 3.
Oh, okay.
What other questions?
Okay. Okay.
Can we do?
You just didn't remember how to divide. We figured it out.
I think I just probably just put.
Can we do 6?
We can do 6.
I
6 is easy, girl, but it's fine. We got this. It'll take a little time when we do another one. Blah, 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 blah.
Why?
Because reasons.
I didn't say why, I said what.
Oh. Blah, 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 blah. You're still saying why. See how deranged our 8s can get throughout the course of the day.
earlier it looked like 6.
Dawn looks like a
It
bear
looks like a
squeezer. It
step
looks like a
stool.
fish. It's a fish with like.
What do we do?
I thought you said 6. Yeah, I thought you said 6.
What?
That's 6.
Oh.
We can do 8 if you want.
Oh, 6 is also easy, but 6 requires us to go back to like when do you learn long division? Probably 3rd grade, 3rd or 4th grade.
4th grade.
Yep. So 6,
I never used long division ever.
I used calculator.
and you can use a calculator to help you get this,
I haven't done long
but you have to like do hand long division to solve these.
That's weird.
Okay, so.
And if you know what you're dividing, why should you just put it in your calculator?
Well, you can use the calculator to like not have to do all the little scratch work of whatever. Like you can use the calculator to do it, but the long division has to be there because we need a proper remainder. Not a fraction, not a decimal, but we need a remainder. Okay, so what does I equal?
The square root of -1.
Square root of -1. What's I squared equal? Negative what? 1. Okay. What's I cubed equal?
Negative I.
Negative I. What does I to the 4th equal? 1. What does I to the 5th equal?
Square root.
Equals I. Okay, so, and then it cycles, right? Yes?
Yes.
That's what's happening? So, anything can come back to one of these 4 things. I, -1, negative I, or 1, right? And then we'll figure out which one that one comes to. We have to divide and see what the remainder is.
Wait, wouldn't it just be negative I? Because like you just go to 1, 2, 3, and then you get negative I.
Where are you getting the 1, 2, 3 from?
Okay.
I'm trying to find out whether you're thinking right or wrong.
60s, it's 5 and 60. So you're like 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. It's gonna happen every time until you get 60, and then just 1, 2, 3, and then you get.
You're doing what we're gonna write on the board, which is what you need to write in the paper. You're doing it correctly and thinking right,
Okay.
and you're thinking right. If the number is crazier than harder to think through, then you may need to whatever else. So what you're doing is accurate. You're kind of thinking right. Okay, so what we do is we divide 4 into 63. We don't really care about the beginning bit, but 4 goes into 63 how many times? Punch it on the calculator. Because you're going to get something point. We don't care about the point, but we care about the beginning for now, right?
Yeah, it's 15.
It's what?
15.
Oh, yeah, duh, because it's, I guess if we did the division right, we probably could have done it in our head. 1, and then there's a 4, and then minus, and there's a 2, and then 3. 4 goes into 23 how many times?
0.
No, 5.
Because we need the remainder. I've said this 5 times already.
5 times.
I know you don't want to do it, but that doesn't change the answer to the question.
5.
5 times. 5 times 4 is 20. The remainder is 3. So this is the same as this because of the 3, yeah?
Wait.
So this equals negative I. Let's do another one of these to practice better. Let's make up something random. Let's do I to the 3,481. How do we do it?
Long division.
Long division. 3,481 divided by 4.
Why do we always do it by 4?
Because that's when the pattern repeats. Because there's four possibilities.
Is 5 not the possibility?
This is the same as this. I was just reminding us that it starts over there. Yeah. 4, 8, 1. 4 goes in 3, 0 times. 4 goes in 34. How many times?
Use a calculator for this one.
Why? How about 8 times? 8 times 4 is what?
32.
Are our math facts oozing out of our ears for some reason?
Hold on. If you bring down
What are you saying? What? You got it? Good. Is your brain not braining any better than mine today?
6. No.
Yeah.
Wait.
How about 7?
Yeah.
Because 7 times 4 is 28.
We're all at the same boat, guys.
Wait, how many times?
That's your fault. You
4
should-
goes into 1 none times, and we have a remainder of 1. So what would this equal?
Negative I. Negative
I, it would equal I.
It would equal I.
Okay, so I did this weird way again. I was just like 1. I just looked at the last one.
Great. Don't do that. You have to show that work. This is the work that I'm talking about. Let's do one more. Yes.
You can't just look at them.
No. No.
Okay, so okay, I got it now.
Let me do one more because the thing that might get you in trouble is one of the possibilities. Let's do one that's like super easy, and it's going to be relatively obvious probably, but
8.
but we're going to do it because I want to show you what's happening. Let's do I to the 36. 4 goes into 36 how many times? 9 times. 9 times 4 is 36. So it has a remainder of 0. That means this equals what?
4.
The same as I to the 4th, which is 1. So this equals 1. So if you have a remainder of 0, so you'll either get a remainder of 0, you get a remainder of 1, or you get a remainder of 2 or 3. Right? So it's going to be one of these. Well,
So
this
0 is 4.
0 is 4. Yeah. 0 means 4 goes into it perfectly. Yeah? Any other questions on this lesson? I bet we need to are we good on like the getting stuff out of the denominator ones? Probably not. Do we need to do one of those, or is there something else we want to look at?
We do 10.
10 was not what I was talking about, but 10 is a little bit sketchy too. So let's do it. It's actually easy, like uber easy, but I don't know that I did one like it in the video, so it's actually real easy. Okay. Excuse me, gosh. Tummy. 10 is 4b minus 5 plus negative a minus 3i equals 7 minus 8i. I'm going to write some work up here, and I want you to look at it, and then I want you to go, oh, okay. But don't do it unless you like have the oh moment in your head, right? So this is what we would do to solve this problem.
Oh, because you like split the thing.
Yeah, so this is an ugliness in complex number notation. This is like a prettiness in a complex number notation. And so this has got to be the same as this, and this has got to be the same as that.
So you just like,
And then you solve those little baby things, and we get answers of whatever they are, negative,
So
whatever.
like why in this case do we not like include any i's?
Because we're looking for A and B.
you just kind of like,
And this is the one that matches the I term, and this is the one that matches the not I term. So we don't need, so we're just making a couple of little baby equations and moving on.
But how does that work?
oh.
Let me write something
Fake numbers and the real
without x's in it, or let me write something a little bit different, and see if it makes better sense. So, what am I going to write? x plus 5 times 10 plus x minus 2 times 12 equals 10, no, equals, yeah, that's great, that's fine actually, 10 plus 12. What do the parentheses equal in this equation? Like without doing any math. What does this equal and what does this equal?
I mean, x plus 5 and...
Yeah, but what does it equal? We can look at that right now and I can tell you what I can cross these out and I can replace them with a number right now without doing anything else.
-5 and 2.
No, that's not right.
No.
Like 10x and 50?
Why?
This side is all this mess times 10 and all this mess plus all this mess times 12 equals just the 10 plus just the 12. So this has got to be 1 and this has got to be 1, right?
Okay.
This is the same kind of idea, right? This in this position has got to be the same as this one, and this in this position has got to be the same as this one because their arrangement, because of the way it works.
Okay.
We could replace the i's with x's and it would be the same.
So the eyes are just
The domain would change a little bit if it were x's, but yeah.
The eyes are just there to make it think harder.
We should do, assuming somebody needs, do we need any of either the like 30 through 34? Which one? Because in case we have time to do, because we probably have time to do one of them right now.
Let's do 34 because it looks kind of annoying.
We need, is 34 more scary than 30 and 32 to everybody? That seems like it looks fine. Either we're kind of barely listening or shrugging sure. Okay. Let's do 34. We're supposed to simplify, and it is 5 over 2 plus 4i. Now, the problem with this, and the reason it's not simplified, is because we don't like, in a simplified answer, having square roots in the denominator. What does I equal? Square root of -1. So we got a square root in the denominator. We don't like that. So how do we get rid of it? How do we make it not into the denominator?
Multiply by the inverse, or one part of
It's a C word.
contricular.
The conjugate is what we're looking for. Thank you.
Centrifugal force.
No, you're in the wrong class for that.
I like centrifugal force. That sounds fun.
Oh, you're at the wrong rally. Lillian got my joke. Nathan got my joke. Okay. Okay. I still cannot hear anyone in the audience saying what people are claiming that they said. I've listened to that clip probably a dozen times, and I cannot hear them saying what people are saying that they said. So, I don't know.
That was a trashy joke.
It was a trashy joke. You're a trashy joke. Okay, so what is the conjugate?
Conjugate is,
Yeah, so we just flip the middle sign. So 2 minus 4i, 2 minus 4i. And we know when we're multiplying something by the conjugate that the outside and the inside are going to cancel. So we don't have to do all of FOIL in the denominator. If it was a binomial up here, we'd have to do it all on the top. But we only have to do full, right? Just the F and the L, because the outside and inside are always going to disappear. That's like the whole point of it, yeah?
it's no longer foil, it's full.
It's full, which you cannot say without a vowel sound, but we get as close as we can to make the point, right? So all we're going to do is the first and the last, yeah? If you do all of it and you forget that, that's fine. You're trying to say it without a vowel sound, you can't do it. Can't do it. Not really possible.
You tell us to try something.
I didn't tell you to try it. I just said you can't do it. Nope. Nope, nope, nope. I just, that maybe saying you can't is the same thing to a teenager, which is why I don't tell teenage boys you can't do like anything physical. You can't jump off that roof. Watch me. Okay. What do we do now?
We do the numbers.
8i, and then like.
I'm gonna do the numerator first, if that's okay with y'all.
It's 10 and
What's the numerator?
21. And then
The
10
top of the
minus
fraction.
I know.
No.
No, I mean, what's
What
the
is the
math you're
numerator?
doing for the numerator?
I'm
And then I
just
realized-
distributing, yeah.
Yeah, then I realized.
And then this goes to the wrong place.
Okay, that makes sense. 4, and then 8, no, 16 16i.
Minus 16i squared. Es muy importante because now the I is going to disappear, yeah?
Yeah,
You
it's
just
gonna
make
turn
that go
into
poofy.
-1, which is 16.
So we've got 10 minus 20. Oh, I think this is going to be a good problem because it's going to give us one more thing we need to think about. 4 plus 16. So we get 10 minus 20i over 20. We would be tempted to circle that and be done with it, but we're not done with it.
We have to divide by.
We can reduce it. What can we reduce by?
10.
10. So we divide everything by 10.
Then we get 1
1
minus.
You don't necessarily have to write this divide by whatever you're reducing by. I'm just for the sake of clarification.
1 minus 2i over 2.
1 minus 2i over 2, and then we circle it. And we're happy because we get to leave.
Can we not, do we not have to separate? Oh no, it's only.
Okay, so yeah, technically yes. Technically this would have to be 1/2 minus I. Yes. Because that's proper complex form, to have the A plus BI. This is the same as this.
But where did the two?
Okay, I'll show you. So the first one, you get the 1/2 part probably, yes?
Yeah.
The 1/2, okay, so the 1/2, and then minus 2i over 2,
Oh.
and then it cancels. Yeah.
Adios, amigos.